the physics problem called the contact problem, which is when you touch something, your hand will bounce, your hand should bounce off like a ball bounce off a racket, but it does not. But when the robot finger touches something, it bounces off. Okay, there's no reason. It's just like ball bounce off a racket. Okay, so this problem hasn't been solved. So this is the one of the fundamental problem in robotics. See, so robot should be defined as an intelligent machine which can come safely into contact with the environment, which today's robot cannot do. Okay, the sixth generation computer science in Japan was dealing with robotics, and it failed because no robot can touch. Robot finger just bounce off the surface like a ball bounce off of a racket. Okay, today what they try to do is they try to touch the surface, touch things with precision. It's very interesting. I guess it's all right to be very carefully and be very precise so you touch something. But that is not really the right way. I'm the founder of pole science. The pole science believe that is not the right way. Okay, that is just use precision. Okay, what we are trying to do is first we solve the problem of contact. How to make a contact with the surface, not bouncing off. The second is not use exact logic, such as scientists do with precision. Science are obsessed with precision. Okay, here we're suggesting a fuzzy logic which will allow range of tolerance. Okay, so today, Poisson estimate that the range of tolerance is about 20, 20 millisecond. Okay, the range of possibility is 2 millisecond. So there's an order of 10 in the range of tolerance. But that's not enough, you see. No matter how careful you touch it, it's going to bounce off. You see, they're going to be bounced. Okay. You should, this is the creation. Our creator create us, also create all the animal, insect with the ability of touch. Okay. Be able to come safely into contact with the environment. Today, the engineers try to do the avoidance. They avoid contact. Okay, so the self-driving cars, they avoid the contact. Okay, the problem of robotic is contact, it's collision. It's not avoiding collision. Okay, so there's a total difference between my my the field I found the pole science and the science. Okay, this is the first issue we have with today's robotics. I think they're doing all wrong. Okay, so what can you say? This is age of science. Okay, I'm founding the age of social science. Another big problem is the software. The software, today's software is partially automated, so it's completely wrong. Okay. The more software we write, eventually we have more and more problems. We accumulate this partially automated software. Today, you have to, every couple of years, you have to update your Microsoft Words. You have to pay Microsoft. You have to pay for update. Okay, this update will become more and more serious as time goes on because all this partially automated software need manual update. Only company with large amount of funds can update software. And what Poulsen has done is to invent the complete automated and self-generating software system. In other words, complete automated software, which can self-generate, which can auto-update and auto-documentation. So basically, we're moving from partially automated software to complete automated software. And I have actually testified in court, in a class action court a case against Microsoft. I said publicly in court, okay, I say software developers should pay for the cost of update. Another Microsoft should make us to pay the cost of update. You see, Microsoft should pay for the update. With complete automated software, the update should be automatic, so there's no cost. Okay, the software can go last to infinity. Anybody, you see, with complete automated software, anybody should be able to write software. Anyone over 6 years old should write software in their own native language, because this software eliminates all the technical barrier in computer usage. So what is significant of the software in robotics? The significance is now we will be able to create a self-generated neural network with unlimited number of software cells to create an electronic brain, okay, just like a human brain, okay. This is not enough. All this AI, they are using partially auto software. They try to use neural network. It's not enough. You see, again, the software has problems, okay, and also the software itself has, there's a limitation, okay. They're doing this. For example, you see, they're using neuron, okay, line up all the neurons. Okay, this is not the way that both sides suggest that we should do. We should have co-neurons with same functionality. Anytime it strengthens the number of co-neurons should increase. Instead, they try to use weight. Okay, so it's sort of what they are doing is just demonstrate the possibility of perception. Okay, the old computer knows how to analyze things. Okay, now we have computer that can see things. Okay, identify things, so that they call it the learning. Okay, sure, this is it is the work of neural network to work in such a fashion. So we need to have complete automated software to create electronic brain, so we can have a true correct neural network. And the combination of the two. Also, we need the fuzzy logic. You see, the thing is not exact. So scientists try to do things very exact. They try to avoid collision, and they try to come into contact very carefully, so there will not be strong collision. Okay, this is not the correct way. Okay, you're supposed to have collision, and how to avoid the collision is a physics problem. Okay, so for this solution of collision, Boson has invented a concept called jump pulse. Okay, in the Newtonian impulse is a sudden change of momentum. The Boson, my jump pulse is you see, you look at my name here. Okay, Hugh Ching jump pulse. Okay, this jump pulse, my name is Hugh Ching. Okay, because I try to promote jump pulse in Facebook, so I put in the name jump pulse. Jump pulse is a sudden change of force, while impulse is sudden change of momentum. Okay, so this jump pulse is a new term. Okay, in physics, they only go up to the second derivative for some reason. Okay, acceleration. They do not go higher. You see, higher than second derivative. Acceleration is a term called the jerk. Okay, they don't go to jerk, and now we're not working in that direction. Work on jump pulse, impulse. Work on this impulse. Impulse is a delta function in momentum, and this jump pulse is a sudden change of force. It's a step function in force. Okay, impulse is step function in momentum. So Basically, there is a new physics involved. In other words, when the ball comes, or a finger comes to a surface, it has the same, once it contact, it has the same velocity. It also has the same speed, okay, because they're in contact. Whatever the hand is moving, they will move together for a very short time. Then afterwards, the ball will bounce off, okay, because of the ball acquire fast acceleration. When it bounces off, then you don't have contact. In order to contact the racket and the ball, the racket must move as fast, must suddenly increase its acceleration. Okay, this increases by jump outs. Okay, you have to suddenly increase. So in sports they have already doing that. Some coaches, I know the best coaches. I'm a good tennis and table tennis coach. I teach people how to hit the ball and carry on the racket. Okay, that is at the moment contact, you suddenly apply a jump pulse. You see this word jump pulse there. Okay, you suddenly apply a jump pulse so the ball and the racket will stay together. And that's the only way to be steady in sports. So because of this contact problem, I predict in 1978 in my book, Table Tennis Scientific Analysis, I predict there will be a great deal of there will be frequent occurrence of double hitting. In other words, when you're carrying the ball will go out eventually. Then there's a tendency for the ball to hit the racket several times. Okay, this problem of a ball hitting a racket and the finger touch a surface is they are the same physics. Okay, so you look at the ball, it's much clearer. I predicted from 1978 that there will be frequent occurrence of double hitting. Okay, and everybody laughed at this and the country this, and I was criticized from that time onward. Okay, until now. Okay, what happened was this. Okay, in 1982, tennis allowed double hitting. Okay, the regulation changed. Okay, tennis allowed double hitting. Tennis people were the first to realize there is double hitting. Then in 2004, table tennis allowed double hitting. Okay, the rule changed. Then finally in 2019, golf allowed double hitting. So because of my prediction of a double hit in my book in 1978, and the double hit is practically legal today. Okay, nobody laugh at me. Okay, I laugh at that. Okay, I have a video which shows myself. I can hit the ball and let it bounce, purposely hit it, let it bounce several times. So the other side just completely collapsed. Okay, I won the whole debate. Okay, with demonstration. Also in software, I have a patent in 1996, which says that software can be completely automated. And this should completely change the foundation of technology. Okay, software is very important. Anything today people can do, they can write in software. And then let the software take over. Okay, so basically, the society, the knowledge community must change into these two directions. Okay, in order to look into robotics. Robotics has, like Dr. Kostler has just mentioned, it's very, very important to have a robot do all the work and a human being do the thinking. Okay, now we don't have robot, we have robot substitute. Okay, today's worker like robot substitute. Okay, they substitute a robot. There's no robot, but the human can work like a robot. Okay, so people are not happy with their work. Okay, so what we need is the real robot to take over all the human robot substitute. Okay, robot does the work and the human does the thinking. Okay, that's the correct society. And anybody who does not want to think, they will be paid some minimum basic income, universal basic income, so they can survive and have children who eventually can think. Okay, so basically humans' job on Earth is to think, not to work like a robot. So robot is extremely important. So it's not something. It's a goal. It's a definite a goal for human beings. So we have not reached that stage, and science is totally insufficient, inadequate in solve this problem. So we're pointing out just two of the basic, fundamental problem with science in solving this robot problem. Hopefully someday, hopefully within our generation, we can at least recognize these two main problems. As you can see that I'm one of the leading authority in robotics, so I think it's very important. Pole science, the leader, no question. So we just lead everything. But our problem is sort of difficult, is it? Because in order to contact and carry the ball on the racket, you have to solve a problem with 25 variables. Okay, it's a spring. The problem is a spring, and there's attack there too. The ball is on one side, the racket is on the other side, and when the racket moves, how the ball is affected. Okay, this is the problem with a spring with 5 variables at two ends of the spring. So 5 times 5 is 25. It's a 25 problem to think. Okay, today the best thinker are probably the Nobel Prize winners. They can think 10 variables because science generally deals with 5 variables. 5 variables for the old, 5 variables for the new problem. So add together 10 variables. The best thinker, the scientist can think 5 variables. Okay, the best scientists can invent new science so they can think 10 variables. Up to now, only Dai Wu, my mentor in physics, who can think this problem of contact. Okay, so one person. Okay, I think that all this audience there, you listen to me. You should try to think about this problem. And if you cannot solve it, you should ask whoever you know to see if they can solve it. They are physicists. Okay, this is a fundamental problem. Okay, Newton said Newton's force is a push and pull of an object. So before you push, you must make contact. If you cannot make contact, you cannot push. Okay, so after Newton, the mainstream problem is the contact problem. But Newton couldn't solve it. Robert Hooke couldn't solve it. And eventually Henry Hertz, a genius in physics, he died very young. So he solved the static contact problem. He didn't solve the dynamic contact problem. So nobody in physics for the last 300 years could solve this problem. So far, only Dai-Yu and myself, and also some pole science students can understand at least understand the significance of the problem. Okay, today's scientists, they don't even recognize this problem. They just sweep under the rug. Under the rug. Okay, make it clear. The scientists sweep the contact problem under the rug. They avoid it. Everybody jointly avoid it. This is really, people criticize science. I'm the person who just describes science, not really so much criticize it. So I just give you the problem with science. They think 5 variables, and they have to be able to think 25 variables in order to solve this problem of contact. the contact problem. And also they have to, the software is even more difficult. It deals with about 500 variables. So it's a problem in life science. So that problem, pole science will handle by itself. Okay, it will take a long time for people to fully realize this. So it doesn't matter. We have students who would do this, but the physicists, because of this current development, current interest in robotics, it puts this contact problem at center stage in technology. And the engineers, the problem with engineers, they just take the equation provided to them by the scientists and try to work on those equations. And that is not, that cannot lead to solutions or new solution in physics. And the physicists must come out and to think this problem. So basically, that's my idea about robotics. You're getting the most advanced view on robotics to compose science. Yeah, thank
Thank
you.
you.